All right. I think we are ready to go today. Hey, Dexter. Good morning, or morning where I'm at. Sorry, I don't remember everybody's time zone. So if it's not morning for you, then good afternoon or evening or whatever part of day it is. And yes, yeah, we are in for a treat today. So we are going to be taking a sneak peek at Adafruit Whippersnapper, this will be the first time that I have had a chance to play with it. I got access to it a few days ago, but I wanted to wait until the stream to really get dug into it. But before we get to that, let's take just a quick step backwards and do an introduction. So hello, everyone. My name is Tim. I go by foamyguy online, like on Discord and GitHub. And on this stream, like I mentioned, we're going to be working with Adafruit Whippersnapper, but more specifically, and in general, what we work on pretty much every stream is related to CircuitPython. CircuitPython, you can find out more information about it right here at circuitpython.org. It's a version of Python that runs on tiny computers called microcontrollers, such as this one right inside of this lightsaber in the photo right here. Or on the overhead cam, we have a Adafruit Funhouse right here. So there is a microcontroller, which is, again, pretty much just a tiny computer. In this case, it's inside of this little metal shield, I believe. And these little computers, some of them have different sensors and different things connected to them. Like you can see on the front here, this one has got a screen. It's got a little speaker there. It's got some buttons on the side here. Oops, on the other side. Oh, no. The buttons are on the front. The buttons are on the front right next to the screen right here. I got my screen protector still on there, so that little tab is covering up one of those buttons. And these are basically just little fun computers. You can hook up different sensors, different lights, LEDs and speakers and all kinds of things. Pretty much any kind of electronical component you can hook up to these devices. And then using CircuitPython, you can write some Python code because CircuitPython is, again, a version of Python. You can write Python code to interact with electronic devices. And probably the coolest thing about it, in my opinion, is that CircuitPython devices, they show up as a thumb drive. So let me go back to the camera here. I will plug in this Adafruit Funhouse right here. We can get it on the camera there. So we're going to plug it in. And what we will see once it is plugged in is that it will show up as thumb drive right here, the CircuitPy removable storage device, and it has a file right on here called CodePy. And for CircuitPython, all we have to do when we want to make a new, make a new program, all we have to do is just open up this CodePy file, put some more, Python in here, edit the code that's in it, and save it. And as soon as we save it, that microcontroller will just automatically run it. So it's super easy to do. It doesn't require any complex software. It doesn't really require much setup. And it's really great for folks who are new to programming or electronics, who have not done this sort of thing before, and who don't necessarily have the experience or the patience to work with complex tool change that take a while to set up and take time to debug when they go wrong and all of that sort of stuff. So that's the kind of stuff we're going to be working on. If you are interested in this kind of stuff and you want to help support the project, it is an open source project, so you're definitely welcome to and encouraged to contribute. You can join us on GitHub, where all of the code for CircuitPython lives, both the main project as well as all the libraries that do all sorts of extra interesting stuff to interact with different pieces of hardware or make it easier to do certain things. All of that stuff is stored on GitHub, so if you'd like to get involved, you can definitely do that there. You can also join us in the Discord, which is on the screen down below. I guess maybe over this way a little bit. adafru.it/Discord. And if you go there, we are in the live broadcast chat room, which is the chat that is right below me on the screen here. So if you would like to hang out during the stream, you can catch us there. But there's also different channels on that Discord, like for CircuitPython Dev or help with CircuitPython and all sorts of other stuff. So that's a great place if you want to get involved in the community and are not yet. CircuitPython is primarily financially funded by this company right here, Adafruit. This is their website, adafruit.com. They are a company based out of New York. They make all sorts of hardware devices, like some of these microcontrollers, for instance. Here's another one of them. There's all shapes and sizes of these little things. So this is a different one right here. They make the microcontrollers. They also make all sorts of the stuff that you can do with the microcontrollers. As you can see here, it's like a LED matrix screen, motorized turntable, some keycaps for making macro pads, 3D printed designs that fit around stuff, the macro pad, which I also got recently. I'm excited to play with that one. So they make all sorts of this stuff. And I would say, most importantly to me is that they, again, they provide the financial backing for CircuitPython. They pay folks full time to work on CircuitPython. So that's really cool. I definitely really like the CircuitPython project. I want to see it succeed. I want to see it stick around for a long, long time. And so that is why, that is one of the reasons that I support Adafruit by purchasing products from them. And that's what you can do as well if you would like to help out without, actually diving in, getting your hands dirty and working on code and stuff. You can always just purchase hardware from Adafruit since they're the ones paying folks to work on this right now. And they do have folks that do streams for Adafruit, like Friday Scott, the lead developer on CircuitPython, does the deep dive stream. I'm sure most of you are familiar with. And this one is a little bit different. I do work for Adafruit. I make guides and other software and stuff for them. But this stream is not necessarily affiliated with them. I like to give them credit up front just for all they do for the CircuitPython, but I'm not being paid for this stream. This is just something I do for fun. So that's the introduction, and I think we are pretty much ready to dive in. So like I said, we're going to look at Whippersnapper. If there is time after that, the next thing that we will work on is, I should have had it pulled up here. I think this is a different PR. Let me run and find this other PR real quick, actually. So the thing that we'll work on after Whippersnapper, if we have time, is going to be related to Display IO. We want issues, and it's essentially this sort of one big issue that we need to take care of, which is kind of going through all the different libraries and removing the usage of max size. That was a parameter that group, the Display IO group, it used to have a max size parameter. You could not add any more elements to it. You could not add any more objects like Display IO objects like bitmaps, or I guess it would be tile grids and other groups and things. There was a max size, so you set it to 5 or whatever, and then once you try to add the 6th thing, you wouldn't be able to. It would tell you that the group is already full and you can't add anything else to it. But more recently, within the last probably, I want to say maybe a month or two, it was actually changed inside of the core, so you no longer are restricted by the max size. You can actually just keep adding things and adding things and adding things, and you will never, the group will never get full. There is a limited amount of memory on the device, right? RAM. So eventually you will run out of RAM, and then, you cannot do anything else after that. So there is still a limit, but it's a much higher limit, and it's not something that you have to worry about explicitly saying, like, here's the max size for my group. And then, you have to keep within that bounds. Instead, it's more like you can just keep adding until the particular device that you're working on happens to be out of memory. And then you got to go and figure out if there's ways that you can be more efficient to try to save some memory. So this will be the thing that we're working on. You can see here, this is a big long list of a bunch of the libraries that need to have modifications in order to remove that max size parameter, because starting with, I think, 6.2.0 or 6.3.0, somewhere in there, versions of CircuitPython, it was basically removed as a requirement. So you used to have to use it for group. There was a default value, I think it was 4, but you had to have it set to something. And more recently, they changed it to where you don't have to have it set to anything at all, and you can always just keep appending things to the group. And moving forward, whenever, I believe, the goal is, the milestone listed here is 7.0. So whenever the stable release of 7.0 comes out, 7.00, the hope is that we will actually remove max size altogether, which will mean that code that does try to use it would actually end up throwing a exception. So of course we don't want that to happen with any of the libraries. So the work that we need to do is go through and remove all of the usages of max group. And as you can see, it's kind of a long list. There's quite a few libraries that have used it. Pretty much any library that did something with Display IO is very likely to have used it. So we're in the process of working on this. Right up at the top here, I would like to give a hug report. I'll put it in the notes for the meeting on Monday as well, but definitely a huge thanks to Les Samurai Porpe for putting together this list, right? This gives us a nice centralized place to work from so that we can, work through this kind of, functionally, I guess. Like we have a place to refer back to and see what's done and what's not done and all of that sort of stuff. So this was really cool. I definitely really appreciate Les Samurai putting this together for us. So again, that's what we'll do after we play with Whippersnapper, but we will start out with this. And so I will say right up at the top here, this is my first time using Whippersnapper, so I don't have any previous experience with it. The only things that I know about it are just from watching Show and Tell. I know Brent has been on a couple of times over the past, maybe month or so, and has shown some progress. So I've seen it in action, but I have not actually set it up myself yet. So that's what we're going to do. We're going to set it up on this Funhouse device right here, and then we'll see what it's all about. We will make some sensors and things in Adafruit Io, and we'll try to get it all hooked up and to the point where we can control that device from Adafruit Io. So this is the help section, right? This is where it tells you how to get started. So that's exactly what we want to do. It is obviously, as it mentions right up here in the warning and right below here, and in probably lots of different places, they have this warning just because this is still in beta, right? This is a public beta. I should mention, if you are interested in the Whippersnapper project and if you want to get access to the public beta, you can do that on Show and Tell last week, I believe. Brent mentioned that the public beta is opening up, and if you would like to get access to it, the way that you can do that is by pinging Brent on Discord inside of the Adafruit Io room. There's a help with Adafruit Io. Here, let me pull the Discord in right here. I think we can see that maybe. Let me make sure. I have my preview on anymore. Yeah, okay, that does show up. I didn't know if it would show up since it's also the chat window in the bottom right there, but this is the Discord window, and you can see right here, help with Adafruit Io. If you go inside that room, then you can just do a ping to Brent RU. Just do @BrentRU, and you can ask nicely for access to the beta program, and they said that they would be willing to share that with other folks as well. So that's what you can do if you want to get involved in this particular project as well. So yeah, I'm just going to start kind of at the beginning here. I have not done any of the setup yet, so you guys are going to get to see, you folks are going to get to see the setup from the start on exactly what we need to do to get going with this new project, or with this new feature, I should say, of Adafruit Io. One thing I'm going to do actually before I get going too far here is I'm going to turn this light on over here. I'll be right back. To be a little bit lighter here. Okay. Let me make sure that I also have all of my previews paused or turned down at least. Okay. Yeah, we're looking good there. All right. So let's see. What do we need to do? I'm thinking we probably need to install a new, CircuitPy or maybe firmware or something on the device, but let's just kind of take a look here. It's in beta. It's being actively developed. If we find any issues, then we can report them using the Contact Us on the Adafruit Io support page, so we'll keep that in mind. If we run into trouble, then we'll go there. Let's see. Get connected. This guide walks you through it. So here's the logo. It's a cute little, is that a turtle or something? I'm not entirely sure, but it's definitely a cute little animal there. Let's see. It's going to turn any Wi-Fi capable board into an IoT device without programming a single line of code. So this is really cool. Like I mentioned before, CircuitPython is really good for folks that don't have a lot of experience, or maybe even don't have any experience with programming or electronics, and this moves further down that road. This allows you to do stuff that's actually pretty complex stuff. Like this kind of stuff, just even like 2 or 3 years ago, like if you wanted to get this stuff done, it takes a lot of work and a lot of, kind of specialized knowledge, truthfully. So the fact that this is now, easy enough, it's been made easy enough, and the tools have been built up enough to where, Folks that don't even have any programming experience are able to do this is actually really, really cool. So let's see, we need to load the firmware on our board. We're going to have to add some credentials because this device here, this Adafruit Funhouse right here, again, the main computer for this is inside of this metal cover. I believe at least it's underneath there. And it does, this is a ESP32S2, and this main chip does have Wi-Fi built in. So this device can access the Wi-Fi network just without any extra hardware. It's all just built in right in there. So we'll have credentials to get it on the Wi-Fi. It will register with Adafruit Io account, which I already have my account set up. And then from there, we add components in order to do stuff. Okay, that seems easy enough. Right now, I just have the Funhouse by itself. I may, once we get going, I may run and grab a couple other sensors and things maybe that we could hook up to it, but we'll see where we end up here. So let's see, the boards that are currently compatible with this are the Adafruit Funhouse, which is the one I'm using right now. Also the PyPortal, which I do actually have my PyPortal here on the desk, so maybe we'll try it out with that as well. And then the other one right now is the Mqtt M4 Airlift. I don't believe I have one of those. I have a Mqtt, I think I have a Mqtt M4, but it's not the Airlift version. I think it's the one that does not have Wi-Fi, so we would not be able to use my Mqtt for that, but I'm sure they're going to be adding more and more devices to this all the time. I think even, I want to say, I'm not 100% sure, so don't hold me or hold Brent or anyone to this, but I think, if I recall correctly, I think Brent mentioned on Show and Tell that the Mqtt ESP32S2 would be one of the next devices that they're working on adding this to. So let's see. Let's kind of just take a quick look through here. Actively developing more devices. Can follow along on the blog or the Twitter account to stay up to date. And the goal is to allow folks to add their own devices to this as well, but that is still in the works, which makes sense. So we've got our device ready to go. Let's head over to the next page here. Install Whippersnapper on a ESP32S2. So let's see. Sign up for Adafruit Io. So I've got an Adafruit Io account. Let's go ahead and pull that page up. Just get logged in and ready to go here. Okay. I am set up here. I'm not sure if it's under dashboards or if it comes up in a new section. We'll just leave this here and come back to it when we're ready. But we are already signed up, so we don't need to do that part. Okay, I believe my accounts are linked already. My Adafruit.com account and my Adafruit Io account, I believe those are already linked. Let's see, install CircuitPython, which I've got CircuitPython installed. However, I don't know what version it is. It's probably worth checking and maybe updating the version here. So I'm going to connect to the serial port here. Is that all I need? Yeah, I think so. And we'll go to the REPL. And what we have right now is a version of 7.00 Alpha 3. However, I do notice this one says dirty, so I'm guessing probably that I built this for some reason, maybe testing a PR or something like that. So what I'll do is we'll go and get a stock version of the firmware. That way we are working from a clean slate, not whatever I could have had on there, which I truthfully don't even know at this point. So we're going to download, I will get the newer 7.0.0 Alpha 3. This will download, and in order to install this on my device, all I have to do is press the reset button twice. It will go into bootloader mode. If I get the timing right, which I did not that time, so let's try again. I think I still missed it. Nope, I think I missed it again. Yep. A little slower. There we go. One of the cool things about this Funhouse device is it has this bootloader screen. It's a little tough to see. Maybe if I come downward just a little bit, you can see it. Which is nice because in addition to the lights are a little harder to see. You can kind of see the glow a little bit against the black there. Those LEDs that are along the top there, those do turn red for just a second and then switch over to green whenever you are in the bootloader mode. So that's one way that you know you're in the bootloader. But the other cool thing about this device, since it has the screen on there, the bootloader has this nice display that's on the screen that tells you exactly what to do. It's hard to make out the text because it's real small there, but it says, firmware.uf2, and it shows the little arrow to show that you're dragging it onto the house boot device, which, if we go back and look at the thumb drive again, this has now changed names. It used to be called CircuitPy, now it's called house boot because we're in bootloader mode. So all we need to do is just what the little diagram says. We just take our firmware.uf2, which is the file we just downloaded, and we just paste it right onto the boot drive. So let's grab that one house right here. Let's just make sure this is the right one. I'm sure it is because it's the most recent download, but never hurts to double check. So we're going to paste that on there. It'll take just a second. And then once it's done, it will automatically reboot. You can see the lights are flashing there to let us know it's working. And once it's done, it will reboot, and it will be running that new version of CircuitPython that we loaded. In this case, my computer freaks out a little bit. What happens is it reboots at the end of pasting that file, and then all of a sudden it's gone. My computer's like, hey, this drive just disappeared out of thin air, which is actually fine. It's just it's doing exactly what it's supposed to do. My computer is just expecting it to stick around. So it pops up that warning sometimes, but it's nothing to be concerned about in this case. And we could check boot out just to make sure that that worked. So we do now have 7.0.0 Alpha 3, and it no longer does say dirty anymore. So this one is a clean, plain build from CircuitPython.org. It's not one that we built with who knows what inside of it. Yeah, Dexter gets that issue on the devices disappearing as well. I'm sure some OSs may handle it better than others. I happen to be on Linux, and it's not even every time either. It's just like sometimes it does it, sometimes it doesn't. I'm not sure what causes it when it happens, but no big deal. So let's head back to the Learn Guide and see what we need to do next. We installed CircuitPython. We need to add the secrets file, and actually, Whippersnapper uses secrets.json, which this is actually a really cool thing in my opinion. A lot of stuff in CircuitPython. Well, let's take a quick step backwards actually and talk about secrets. What is secrets.json? Secrets.json is a file that's going to store things that are meant to be secret. So like your Wi-Fi network name, your Wi-Fi network password, your Adafruit Io username, your Adafruit Io password, any tokens that you need, like for accessing online services. Like if you are hitting a weather API or something like that, they might require a token. You can put that token inside of the secrets file. And the idea is you put all your secret information in that file, and then you can still check in the rest of your project into version control, like on GitHub, or share it on, Learn in a Learn Guide, like learn.adafruit.com. You can share your project with folks, but you just don't include the secrets file. And that way, when they download the project, they add their own secrets file, they put their own information inside of it, and then it works the same on their end, but obviously it's going to connect to their Wi-Fi network with their credentials instead of yours. And this is actually a little bit interesting that it is secrets.json because up until now, most things have used a file called secrets.py, secrets.py. So it's a Python file that contains a dictionary that holds those secrets. The slight issue with that is that the way that you import it in Python code is by saying import secrets, or maybe from secrets, import secrets. And the problem with that is that CPython, quote unquote normal Python that runs on a PC, it actually has, let's see, this is our TO. We could go here maybe. So if we go like this, we are in Python 3.85. This is standard old C Python. This is not CircuitPython here. And what we will see is that secrets actually exists as a Python module in CPython. There's a built-in module called secrets. I think it's used for generating random strings that are secure. Possibly that's what it's used for, maybe something different. I'm not 100% sure. But it does exist in CPython. And that has actually been a little bit of an issue because it makes it difficult to write code that's portable between CircuitPython and CPython, because lots of CircuitPython examples used secrets.py, and if you try to go to CPython and import it, it won't work because it's going to get the built-in module. So looks like they've changed it up to use a secrets.json, which I think is actually really cool. I'm super on board with this because I would like us to get away from secrets.py. That way our code can be portable and it can run on CPython the same way. So enough about that. It is really cool. So what we're going to do is we'll download this maybe, because I do not have secrets.json yet. I do have a secrets.py, I'm sure. I'll download this, and of course this one is just basically the template. So you can see here I do have a secrets.py. I'm not going to open it because it does have, obviously the things that I want to keep secret inside of it. So here's the secrets.json, and what I'm going to do is just move this off the screen for just a second. And let's see, how am I going to do this? I'm also going to open secrets.py. Is that going to open on this screen? Here's what I'll do. I'm going to open Mu. I'm going to move that off the screen, and then I'm going to go load secrets.py. I'm just going to copy this stuff over real quick. I know obviously you guys can't see this, but that's kind of how it is because we don't want folks to know my secrets. So we're going to fill in the network SSID, the network password. We're also going to do the Adafruit Io stuff. So username for Adafruit Io and the key for Adafruit Io. I'm going to save that. I'm going to close this file. I'm going to close this file. Okay. We have no more secrets on the screen, so I'll bring this back. Minimize that for now. We'll use it in a minute. So now I have my secrets.json. It is filled in with my own information. So let's see what the next step is here. It's telling us how to fill it in. It's just telling us where to find the key for Adafruit Io, which, if it's the same key as the rest of the stuff, let's check here. Okay. Yeah, you would click on my key. Again, I'm not going to do it right now because it would show the key, which you are supposed to keep secret. So I've already got mine, and I've got it pasted into the JSON file. So next thing we need to do here is download Whippersnapper. So if you're previously running CircuitPython on your board, always back up your code before installing Whippersnapper beta. So, again, this is beta software. It's not necessarily ready to go yet. There could still be issues with it. So this is just in the interest of being extra safe. If you're going to try it out, you should back up the stuff that's on your device. So I will do that. I think what I'll do is just take a copy of everything that's on CircuitPy drive, I think. There's a command line tool that helps with this. I don't recall if I have it installed right now still or not. So what I'll do is I'll just do it manually for right now. I think I'll just go funhouse backup. I don't think there's anything super important on my funhouse, but it's okay to back it up. That way, just in case if anything goes wrong, we can always get access to it. Let's see. Can't do it click and drag. So we'll copy this stuff. We'll paste it in the backup here. Okay, now we've got everything nice and backed up. Oh, jar. Yeah, that's a good idea. Jar CVS. There's what is it? It's I think it's called Blinka CLI. Blinka CLI. Is that right? Maybe I got the name wrong. What is this? Git memory. This is foamyguy stuff. Whoa. Interesting. Like, here we go. BCR, but yeah, this is it. So it's actually GitHub BCR, like a CLI. So this is a third-party thing just made by a member of the community, BCR right there. This thing's really cool. I think there's a way you can do, there's a backup command. There's also a sync command, so you can keep like a local copy in sync always, right? It will just keep all the same files there. This thing is actually really cool. For right now, though, I'll just do the quick backup, and I'll look into using jar as well. That's kind of nice to have a little one-liner to do that real quick. So let's go back to here. So we have a new UF2 we want to install. We're going to do that. And while that's downloading, I'm just going to check one thing here. Let me see. Okay. Oh, okay. Alrighty. So this should be downloaded. If we go back to downloads, we have Adafruit Whippersnapper. So this is a UF2 file, so we basically need to do the same thing that we did before, which is double press reset at the right speed, which you can see I've not quite mastered on this device. And then we're going to take the UF2 file, copy that. We'll just go paste a copy into our boot drive. Whippersnapper. I'm curious, actually, while we're here, is this a build that's in the main repo, or is it... Yeah, we got our little error there again. That's no big deal. Adafruit. Whoops. Let's just go CircuitPython. I'm kind of curious. Is this in ports, boards? Oh no. ESP32 boards. No, not in this one at least. Maybe it's in Brent's fork, or maybe it is not public yet. Oh, okay. So hey, look, we got we installed that UF2. And already right away on this dashboards page on Adafruit Io, it just automatically found this. So like I didn't do anything besides install that firmware, and this popped up right here. So this is actually awesome. Do we want to change the name? I think we could just keep the name the same. Maybe we should just take one quick peek back here and just make sure that there's nothing else we need to do. So we did save our secrets JSON. We copied our UF2 file, and it showed up right here, just like it said it would. So yeah, looks like that's all we need. There are some FAQs here. Let's take a quick peek at these. RGBs are stuck on CN. Board's unable to connect to the Wi-Fi network. Reinstall CircuitPython, verify secrets JSON. If they're stuck, so CN means it can't connect. Blue means board is unable to connect to Adafruit Io. So go back to CircuitPython and check your AIO username and key. So that's cool that they use the NeoPixels there as debugging output. Why do I need to install CircuitPython? We've not yet ported tiny USB library for Arduino to the ESP32S2. We'll do that soon. This means that your ESP32 board won't show up as a Whipper drive when you plug it into your computer. This page uses a temporary workaround. Okay, so basically the deal is like, now that I have the Whippersnapper UF2, my device is no longer showing up as a drive. So eventually it will, right? They say this is the idea that, eventually it will show up as a drive. It's just not ready yet. Again, this is early beta stuff. And so the way that we get around that is just by switching back to regular CircuitPython, which of course shows up as a drive just like we're used to, and we can paste our files onto it that way. Yeah, Blinka CLI, it is really neat. There's lots of neat stuff in there. There's tools for font, there's tools for managing devices and stuff. I look at it as a really nice kind of like goes in conjunction with Circup. Those two together provide you a lot of really neat abilities to manage your physical devices through the terminal, if that's the kind of thing you like. Okay, so last one here just says if your device is not listed, basically be patient, because they're going to be adding new devices all the time. So we don't need to install it on the SAMD51 because, well, we would if we want to do the PyPortal. We'll save that for a little while, though. Let's do the Funhouse first. So we'll come back here if we end up doing the PyPortal. It would be this one would be the UF2 we use. But for now, I'm just going to head over to Overview. And it says, okay, we've connected our board, now what? So what I'm going to do then is head back to Adafruit Io. It does say new device connected. I'll just leave the name default. I'll go continue. So now we've got our device showing up here. It says it's online. I'm guessing somewhere, like if we go back one, yeah, we could see a list of all the devices. So if we did add a PyPortal, it would probably show up as another device just in this list here. And then, of course, we can click into whichever one we want to get more detailed information about that device, and I assume interact with it by adding components and things. So let's take a look back in the Learn Guide. Okay, it's just going to show all of our devices. Yep, that's the list page we just saw. Shows each one individually, whether it's online or offline. That's really cool. It's a virtual inventory of your boards. Yeah, okay, so it is io.adafruit.com, and then your username, and then Whippersnapper. That's where it gets you to the list of all the boards. And I assume probably once it comes out of beta, I'm guessing they'll probably add a link or something up at the top or somewhere. For right now, you just have to go to it. This one does not have the username in it. Does that work the same? Yeah, okay, it just added my username for me, so that's nice. Okay, so on a device page, clicking on the device list will bring you to the device page. This page is an interface for configuring anything physically connected to your device. You may think of it as a view of the state of your device at any given time. When you first register it, it's going to be empty. So let's make a new component. Which component do we want to set up? Do they say here? Let's see. It's all sorts of stuff you can connect. Sensors, buttons, LEDs, NeoPixels, displays. So when you click New Component, your hardware will automatically connect to and configure the component using the settings you specified. No coding is required. Additionally, component also sets up a unique Adafruit IO feed, which this part, Adafruit feeds and dashboards, that is the existing stuff in Adafruit IO. Any folks that are familiar with Adafruit IO will recognize feeds and dashboards as the main things that exist in there today. So it's going to also create a feed. I need to set up components every time. Nope, it remembers the components. When you reconnect it, it will have all the same components that you configured before, it looks like. Actively working towards adding more components, just like adding more devices. So the list might be limited now, but of course they are in the process of adding more. So let's, I think we'll just follow along with the guide. I think there's 2 more pages here. We'll just go ahead and work on those 2, and then we'll kind of explore for a little bit. Go off the rails, maybe see what we can find. So if we want to do an LED, so most development boards do have a built-in LED, which the Funhouse does as well. It's a real tiny one right below the screen there. So we are going to go add a new component. And let's see. Ours is online, so we don't need to worry about this. But if it was offline, we could do some troubleshooting steps to get the network set up. We go new component. We go, I'm guessing LED. Yep. Create an LED, give it a name, give it a pin. So let's do that. Go to our device page, new component, LED. We'll give it a name. Let's say built-in LED. Whoops, built-in LED. I wonder if these names are across all your devices. Like, should we call this Funhouse built-in LED? That way, if we connect the Pi portal later, then we don't have two things called built-in LED. I'm not sure. I think I'll do that just in case. Let's do that. This way, I assume the feed name will probably take this name as well, or some form of it. Maybe take the spaces out or something. This way, it'll be nice and clear which one is which. And we are just using the built-in LED, but I am curious to just look through this list here and see all the pins that are listed. So we go create component. So now we have Funhouse built-in LED. This is a component, and that might be all we need to do, honestly. I think if we can get these, maybe, let's see, let's do it this way. Oh, this is the wrong, grab the wrong window here. Let's shuffle that one back. Let's pull this one down, and then one more thing. Let's put Whippersnapper over here. There we go. And I don't know how well the light will work. Maybe I could turn off the camera light if it's not very visible, but let's just try flipping this. Can we just flip the switch? We set that to on. Oh yeah, it did turn on. Let me do this for now. This will make the focus not as good probably, but you can see there the little red LED turned on. It makes it easier to see the lights. So if I go back to off, wow, look at how fast that is. Man, there is something magical about even just flipping lights on and off through a switch through the internet like this. That's just super fun. I always kind of have to just click back and forth and watch it go. Okay, so I mean, you can see this was super easy. All we had to do was load our CircuitPython, fill in secrets, load the Whippersnapper firmware, create this component, and now, we can control this LED from anywhere in the world. Right now I'm sitting right next to the device, but the real power of this is like, I could be anywhere, right? I could be at my office at work, I could be on vacation, I could be, at the Adafruit headquarters in New York, and I could be controlling my device. As long as it's connected to the internet, and I am also connected to the internet, then I can come to this page and flip this light on and off right now. So that is super, super cool how easy that is to set up. Yeah, for sure. Let's give it the old blink of computer there. So let's see, what else can we do here? Open the LED pin. So we got our pin selected. We created our component. We've got the switch. So when we did create component, Adafruit Whippersnapper sent the message to the board to configure the LED. And it also created a feed for storing the component's history. So when we click the switch, it sends it another message to tell it to toggle the LED. Oh, nice. I like the way you have the ring plugged in there. Let me open that a little bigger. Let's see if we can pull this over. Yeah, that's cool. I actually didn't realize, I mean, I guess it stands to reason, but I actually didn't realize you could use those pins at the top. I think the kind of primary use case for those is a light sensor, or I mean a PIR, a motion sensor that uses light, but it senses motion. That's actually really cool that you can connect other stuff to there as well. And so you got the NeoPixel ring there. Super cool. what looks like maybe Nintendo DS. Is that a DS? What do they call that thing? Little pin thing? Stylus, that's the word. Let's see here. Okay, so we can toggle it. Very nice. That's it on the LED page. Let's go over to the button page. We'll set this one up as well, and then maybe we'll go, this is the last page in the guide currently. You know, again though, this is beta stuff, right? I'm sure they'll probably be adding more to the guide over time. So there are 3 buttons built into the Funhouse. They're right along the left side of the screen right there. So, you know, theoretically, we could probably make 3 components, 1 for each button, I'm guessing. Let's try that. So let's go new component. Let's take a peek through here. So we have toggle switch, potentiometer, PIR sensor, magnetic read switch, light sensor, a brake beam sensor, and a water sensor. Let's see, what do I have access to of those? Sure, I've got a toggle switch somewhere. I'm not sure how easy it will be to connect. I've got magnetic read switches. That's going to be the same thing, though. They've just got wires. PIR sensor I've got somewhere. I'm pretty sure I've got a water sensor as well, although I'm not sure if I have an easy way to get it wet. Could drop a little water on it, maybe. Let's do a button, though. Let's follow the rest of the guide real quick. So, Funhouse. I'll call this one... I think we'll do 3 of them. We'll do 1 for each button, I think. And let's go, so we'll do the up first button, up, or up button, either one. Return interval. Let's see what it says about that. There's a new component picker. Select the push button. Select the pin. Return interval specifies how often the board reads the push button's value and sends it to Adafruit Io. Setting the return interval to on change, which I believe is the default. Yeah, that's what it defaulted to. It will tell the board to constantly pull the button, and if the state changes, like when you press it or unpress it, then it will send the new value to Adafruit Io. So then you could do periodically instead. It'll tell the board to read the push button's value every, certain number of seconds, like every 30 seconds or 5 seconds or whatever you want. Okay, so I think we want on change to start with. That way it is, instant more or less. Maybe not. I mean, it's got to travel through the Wi-Fi and out to the internet and stuff. So it's not like, maybe actually instant. It's going to take a few milliseconds, depending on your internet setup. Probably less than a second, though, I would guess. So we'll go on change to start with. And it does say just click create component. So let's go ahead and do that. We want to do a pin pull direction. I think we'll just leave it default, right? I don't know which way these buttons go. This one does not have that checked, so I think we're good to leave that default. Create component. Let me scroll down. One thing that's nice is that I have my browser nice and scrunched here, and this page does readjust itself. So like you can see, if I make it bigger, these things shift to take up more space, whereas if we go back to the halfway, they kind of get stacked on top of each other. So that's nice that this page is supporting windows of all sizes. We've got our push button. So, and it says currently unpressed. And so if we press it, yeah, it changes right there. So, and super quick, honestly, like definitely less than a second. Like I said, it's real fast. And so we could set up the other ones as well. Why don't we go ahead and do that while we're here? So new component, we'll go push button again. We'll go button down. Funhouse button down. Maybe we'll do one of them periodically. What does it get in here? Just pull up and pull down, okay. we'll say button down. Now we've got both of these, and we press button down. That one will change now. We press them both. They both go to press. If we let go of both of them, we can turn the LED back off. That is super cool. And the last one is select. Let's do that one. Let's try periodically. Let's see what that one does. Oh, I probably am hiding the chat here, aren't I? Nice. Okay, periodically, looks like 30 seconds is the minimum that it has there. It looks like you could type, but this is really just for searching. So I wonder if it remembers, like, do you have to hold it down for 30 seconds? Or if you press it within that 30 seconds, then it updates at the end of the 30-second interval. That's what we can find out. We do want button select. You know what I just noticed? It's not letting me select up and down. I assume because I've already chosen them. It does select up automatically. I wonder, would it give me an error if I saved it? It does. Look at that. Yeah. So it knows that button up is already in use. So this is nice. It won't let you accidentally set up two components on the same pin, because of course they would interfere with each other. So we'll go to select, create component, and it looks like these are just coming in, you know, chronological order, like as I add them. No drag and drop for right now. I'm sure, you know, at some point I'm guessing they'll probably have the ability to rearrange these, or maybe even I can't do new link. Interesting. Dashboard. Maybe at some point, and again, I don't have any inside knowledge into this, so it definitely might not turn out to be the case, but I could see a world where they might integrate this with dashboards, where you could add those like whippersnapper, you know, panel to your dashboard and control it from here. That way you can kind of, you know, build up all the stuff around it that you want to see, and then in that case, of course, you could drag and drop them around and do whatever you want with them. So we've got our select button now. I did not name it very well. Can we rename it? Let's see, I got a little distracted. Funhouse button select. Yeah, looks like we can rename. Update. Yeah. Here we go. That did change the order. Oh, you know what? I guess maybe they're alphabetical? Yeah, they must be alphabetical. It must be alphabetical, not chronological, because it's going Funhouse, BUI, and then BUT for button. BUT again, we got the D is before the S is before the U. These must be alphabetical. Button select is our new one, and that one is on the 30-second interval. So if I press it, and release it, will it update? One thing we could check is the history graph. Okay, so it's basically, it looks like it's taken a reading. We can do it this way. Looks like it's taken a reading every 30 seconds, and then yeah, it looks like it's just taking a reading every 30 seconds no matter what. So we got one at 11:01 in 30 seconds. We'll get another one at 11:02. And it does look like you probably need to have it held down when it does actually pull it. So there you can see it switch to pressed. And if I let go right now, it will actually stay on pressed until that next 30-second interval when it updates. So the interval one is probably not what you would ordinarily want for buttons. My guess is in a real-world scenario, you probably will want the on change for the buttons, and the interval might be more for like a sensor, like if you had a temperature sensor or humidity sensor or something like that. you know, you could have it read like once every 10 minutes or something, right? Because, you know, in most cases, the temperature, like if you're just trying to get the ambient temperature of the room or something like that, it's probably not going to change too much from, you know, 10 minutes to the next 10 minutes. So that's probably more what the interval is meant for than stuff like buttons. You can see, though, it did switch back to unpressed there once we got our 30-second interval. And if we look back at the graph, we can see that we had one reading there at 11:02:09. So I guess we're on the nines. So we're on 09 and 39. I guess probably just based on what time it was when we turned it on. So this is cool. It's just built into Adafruit Io feeds, so you automatically, without setting anything else up, you just get the history of all of your stuff here. So this is super cool so far. Let's take a look back in the guide and see if there's anything else before we just start venturing outward some. Should see a new button, so we got that. Okay. Let's see, almost finished with the coffee here. Got my water ready to go, though. So let's see. Also creating a feed. Yep, we saw our feed there by clicking the graph. So by default, those feeds, of course, this is the same as it is with regular Adafruit IO stuff. This isn't specific to Whippersnapper. Those feeds do. I see these LEDs blink every few seconds. Caught it out of the corner of my eye a few times. I don't know if that's like maybe, I'm not sure what is causing that or what it indicates. My guess is it's something like just a, you know, heartbeat or something like that, just letting you know it's still working. But yeah, where I was saying before though is, you know, default Adafruit IO behavior, again, not specific to Whippersnapper, is you get 1K of data, and it will store up to 100 values, and each value can be 1K or less. The other thing you can do though is you can actually turn off history, and then it will only store one historical value, but your value can have more data. It can go up to 100K. So you kind of get like 100K of storage for a feed, and you know, you can either use it as 100 1K values, or you can use it as a single 100K value. We played with that a few weeks back when we were working on the screen thing that shows images on the Funhouse screen. We were doing the 100K so that way we had enough to store those BMP images. Okay. Let's check out FAQ. Did we see the FAQ before? I don't remember. Let's see. Able to send 60 data points per minute. Okay, so oh, Adafruit IO Plus. I don't think I have Adafruit IO Plus yet. I haven't done that. $10 a month or $100 a year. I sign up for that one of these days. Using the free one, you can send 30 data points per minute. So every 2 seconds, you could send a new data point, which we are currently set. We've got one interval, which one thing that's important to note, this the select button, the one we did the interval on, it's continuing to send once every 30 seconds, whether or not we press the button. Whoops. It's always going to send, you know, either that 0 or the 1 based on whether or not we press the button. Whereas the on change ones, if we go back, like button down, it only sends a new value when we actually press it. You can see the last one here was, you know, 9 or so minutes ago, 10:58 something. We can see these values somewhere. Let's see. We could always download it. Go JSON. Oh, it's got to build the link. Let's see. Download every 10 minutes. We did that. We're doing pending. Or 1 minute after refreshing. So does it update here? I don't know if I've ever downloaded data out of here, actually. Ah, yeah, there we go. So now we're ready to download it. And if we look in downloads, what I like to do sometimes is inside PyCharm. PyCharm has Json formatting. So you can make like JSON file in here, you can paste data. Oops. Paste data, and then Control-Alt-L, and it will format it for you with new lines and stuff. And so here we can see a list of all the data that came from our button. Each one gets a unique ID, has the same feed ID, of course, because this is all coming from a single feed, and then the timestamps are all right there. So you can see, you know, looks like those are UTC time. Is that right? Yeah, UTC time. Is that right, though? Maybe not. Hold on, because it's 11... Yeah, that's right, Yeah, because it was 10, this was 10:58 my time. Yeah, 10:58 my time. And I'm either 5 or 6 hours. It depends on daylight saving time. Half the year I'm 5 hours away from UTC, and the other half of the year I'm 6 hours away. So we must be 5 hours away right now. I can never keep track of which is which, truthfully, though. So that's cool. We can always fetch all of our data out of there. Yeah, so this is really neat. Let's go back to the Whippersnapper page. Can we take individual feeds offline? Oh, that's a good question. Let's try feeds. Go feeds, view all. So by default, feeds go into groups. Actually, it looks like the Whippersnapper feeds don't show up under feeds, so they exist, but it looks like they're only visible from the Whippersnapper page. So if we go back there, let's see. It does have an add to dashboard. Let's look in here. So you could trash can it. That would delete it, which would turn it off, but it's kind of permanent, right? If you wanted to get it back on, you'd have to come recreate it. Update component, change component type. I don't see like a temporary, maybe device, what's in here? Device name. So we could change the name if we did want to update it. Let's take a quick look through here. As a key. Privacy. So you can either make your feed public or private. In this case, it's set to private. If you wanted it to be like, you know, have third parties access it, like if you wanted to have your friend be able to change your NeoPixel or something like that, you can make it public. This is how you set up the sharing. Feed history. This feed is online. So, I mean, that implies that the feed could be offline. Not sure. Ah, here we go. Yes. Yeah, looks like this is for it. So we go in here. Yeah. Oh. But then you can't reactivate it. So, I mean, it's kind of the same as just deleting it, I guess, right? License. This must be a newer thing. Looks like they don't have... Oh. Well, they are in there. Just a little hard to see them. There's a non-commercial... I think that's the only one in there. Oh no, there's two. There's a no derivatives and a share alike. A little hard to get it to stop on that one. Does that do the same thing on a big screen? Yeah, it does. This would probably be good to make this dialog bigger so that either make the dialog bigger or make it so the dropdown can go outside the dialog. I have somewhat limited experience with HTML and CSS, but from that limited experience, I suspect it may be difficult to get the dropdown to go outside the dialog. Yeah, that's what I'm thinking too. If you disable it, I don't know why. I guess if you disable it, the main upside is you can disable it and then still download the data. So it'll keep the data for it, and you could always export it. You do have to export it, it looks like, specifically, though. You can't just do a full account download and get it. You'd have to go to that feed and download it. Yeah, I think you're right. Yep. If you want to add, or if you want to keep the data but not keep adding to it, you could do disable. I wonder, I mean, maybe one of these days they'll make it to where you can re-enable it. That would be kind of cool too. That way you could just temporarily turn them on and off. Okay, let's see. So data rate, speed limit. Right now, free accounts are limited to 10 components up to 2 devices. So you can have 10 total components split up between your 2 devices on a free account. So, and then a paid account, if you got the card, again, that was, I think, $10 a month or $99 a year. You get unlimited devices and looks like unlimited components as well, but only 60 data points per minute. So depending on the components that you set up, you just have to keep your, data limit down to 60 per minute. So, averages out to 1 per second. If you absolutely need more, looks like you can maybe get in touch and get a higher rate or something to have more, have more stuff. Do they have this for storage, actually, though? This is something I was interested in when we were working on the screen stuff. I would really, really like to have more than 100K if possible. I would definitely, if that were like a boost thing, I would definitely be interested in that, because it'd be nice. Like sometimes the images came out to, I was noticing like the images could come out to like, 3 to 500K, which is more than 100 obviously, but not like, not that much more. It'd be really nice if we could do those. Doesn't look like it right now. It looks like the boosts are the rate, how many things you can submit per minute, and then how long they get stored. The base time it gets stored is 60 days. You can add additional days by paying a little extra. Okay, so that gets us to the end of the FAQ. And let's just play around with it a little more, and then we will dive into the Display.io group stuff. Get the chat back here. Okay. So this is an old tab, I think. I just never clicked over to this tab for a while, because we already connected this device and stuff. Need to disconnect and reconnect the device. I think this already happened, though, honestly. I think I'm going to close this tab. We'll go back here. Yeah, we already have our device here. Okay. So let's check out the online offline thing. So if I switch it back to here, if I unplug this, So this is now off. See how long it takes. I think Brent mentioned 30 seconds or something. Yeah, that was pretty quick right there. Just a few seconds it noticed it was offline. And let's see here if what happens if we turn this off? What is this? Not currently connected. You'll see your changes reflected in hardware when you reconnect. Or, you won't see them until you reconnect, but same difference. But let's plug this back in and see if it does turn the light off. Plug in. Yeah. It's doing its connecting. So we had CN first, which meant it was connecting to the network. Then we had blue, which meant it was connecting to Adafruit Io. We had a couple other colors there. Maybe it was yellow and it blinked green a few times. And we do have this LED turned off now. And if we switch it, yeah, it'll come back on. So that's actually really cool too. You can change your whippersnapper values while that device is offline. Like if your Wi-Fi just went down for a second or anything like that, like, IoT devices connect over Wi-Fi, and Wi-Fi is not always the most reliable thing in the world. Oftentimes, at least my devices tend to, sometimes they'll fall off for a few seconds here and there. That's really cool that it notices that it's offline and that it will update it. It'll update it automatically. Oh yeah. Sorry, I should. What should I do? I think maybe it would make more sense to do this. Yeah, sorry, I forgot about the chat window there. I like to do this zoomed in one and make this thing all small. It makes good use of the space, but it does end up getting covered up by the chat. Or the other thing we could do, maybe we'll want to play with the windows too much, but the other thing I do sometimes is I'll put this one here. And what we can do is just unzoom this one. So it's a little smaller, but it's got a big old blank section down at the bottom there, which means that it does not end up covering up the camera. Yeah, it's a little better. Thanks for the heads up on that, Dexter. Okay. Let's see, YouTube. Let's pause my music. Let's get that running. All right. Let's look at the other components again. Do I have anything? This is interesting, the way there's blank ones here. Is that because toggle switch came to 2 lines, maybe? I'm sure I've got a PIR somewhere, but I don't know where. It's probably not just ready to go. Kind of the same thing for a potentiometer, light sensor, and a read switch. Water sensor. Let me run and see if I can find my water sensor. I think I want to say that I threw one of these into one of my recent orders, so it might be easy for me to find. If it's not looking like it's super easy to find though, then we'll skip that. But give me like maybe 2 or 3 minutes. I'll run and see if I can grab that, and if not, then we'll just move on. So I'll be right back. All right. Indeed, I do have a, we'll show maybe the tag first. This is, let's see, the light would make it a little easier to see maybe. Let's get that back on. Oh, and I have my focus is a little different now as well. It does not autofocus. I turned off autofocus and set it to manual there. Let's see if we can get that in focus. So the water level sensor, Adafruit product number 4965 is what this device is. So I will do the honors here. I haven't even cracked into it yet. Let's see if we can do this without scissors. Yep, okay. So this is the device itself. Maybe we'll zoom back out. So there's our water sensor. It's got the 3 pins down at the bottom there to plug it in. And I'm not sure, to be honest with you, how it plugs in. So why don't we head over to the product page and then we can see, we can check out the guide for it. What did I say there? 4965 or something? Let's see. Yeah, 4965. Water sensor. And this is the way I like to go and figure out how to use my Adafruit stuff. You know, one of the really nice things about Adafruit, they have a ton of these learn guides. In fact, they published the 2500th guide, 2500 guides. So there's guides that cover pretty much every product they sell. So if you didn't know that, that's like one way you can always learn how to use your Adafruit projects is you go to the page, the product page, and then scroll down a little bit, and usually underneath technical details, there'll be a learn guide section. And some products have a learn guide like specific to that product, and then some of them have a project that actually uses the project. So the product rather. So in this case, it's a pet bowl water level sensor, but it's going to show us how to connect and use the water sensor here. So let's go to wiring and take a look here. So this is kind of interesting wiring. I wonder, could we use... No. Looks like we can't use the PIR, because that's got ground positive and then an IO pin, whereas we need two IO pins and one ground. Although this does say plus. I think that's high, but these both go to white. Let's see. Connect the white wire from the JST connector. Yeah. White wire from the JST connector. So that's talking about on the sides here. There's 3 of these JST connectors, which is just a little 3-pin. Well, one of them is... Oh no, they're all 3 pins. Yeah. There must be a stemma somewhere as well. Yeah, there's a stemma right next to them, which is 4 pins. Or stemma QT, I guess it's the small one, but... So it says black wire goes to minus, which is ground. White wire, one of them goes to A0, and that's the plus one. And white wire goes to A1, and leave everything else unconnected. So you know what I don't think I have is... Let's see, we could breadboard it maybe? Don't think I have all of the right, little connectors to make that easy. Because of the way it needs to go to two different ones of those JSTs. Let's see here. Maybe we can grab a breadboard 2 white wires are a hack. The water sensor was originally presented. Oh, I see. I see. Yeah, I do. Actually, I do remember. Now that you mention that, I remember Melissa saying something about that. Like, Melissa was working on the algorithm that makes it able to do that. So I guess that makes sense. Like, if you go just negative, positive IO, then you can get, digital, like on off. Is there water or is there not water? Whereas if you do it this way, you go negative to ground, positive also to an IO pin, and then signal also to an IO pin. I guess you can modify the power that's going to it, and then from there, when you measure it, you would be able to tell. I think the idea is like how far up these little stripes the water goes. You know what else I want to try as well, actually? I want to try the touchpads. I'm gonna try the touchpads. Let me do that first. I think I'll run and try to grab a breadboard. We'll see if we can hook this up. I'm not sure if I've got all the right connectors. If not, we'll skip it for now. But I want to try this first as well, because I just remembered this device has touch sensors. And I think we might be able to just tell it that it's a push button. Let me go to here, and here, and here, and out. Let's look at what pins the touch sensors are on. User buttons, here we go. They can be used. Oh, got a little typo there. I have permission to edit this page? Do. Is that really a typo? Sometimes, I don't know. Sometimes I'm not. Definitely I'm better at writing code than I am at writing English, so I don't always trust my gut. They can be used to like buttons. Maybe it's supposed to be they can be used like buttons too, with I think that would be the other two with 2 O's. Let's just read the whole sentence here. On the front of the board, to the left of the display and along the top, there's 3 capacitive touch pads with ravens on top, labeled CT6, 7, and 8. The pads are on cap 6 or GPIO 6, cap 7 or GPIO 7, cap 8 or GPIO 8. They can be used to like buttons. Yeah. I think they can be used like buttons. I think that's probably better. They can be used like buttons. Why don't we make that little quick typo change here? Wake up DSP, so this is a different section. There we go. I don't know why my find is finding that. Can be used like buttons. Okay. And then let's immediately just get back off of editing this so that we don't accidentally click anything else. Oh, too far. Can be used like buttons. There we go. So GPIO 6, 7, and 8. Let's see if Whippersnapper will let us put a button there. Push button. D6? That's probably it. Touch, well, let's go funhouse, touch, pad 6. We'll do on change, touchpad 6. So I'm not sure which one is which. Does it? Let's see. Where do I put my like camera? Did I get rid of the camera? Oh no, there it is. So it is a little tough to read through the camera at least. Okay, so 6 is this one over here. 7 is this one up here on the top left of the screen, and then 8, I'm guessing, is that last one there on the top right of the screen. So 6 is the one we set up. So that's the one we'll use. Let's go that there, this here. Touchpad 6. We touch on that? Oh yeah, look at that. So it is going up and down real fast. I think that's probably, there we go. Yeah, something that's just do it with my hand. Hand is a little bit dry. Well, that one did get stuck there unpressed. Let's see. Yeah, now it's stuck saying pressed. Let's try one of the other ones too. Oh, I see. So yeah, the thing about touchpads, as compared to buttons, touchpads are a little bit more analog than a traditional button is. Like the touchpad, it's taking an analog reading and then checking for a threshold. And sometimes just depending on the conditions, like, your fingers, whether or not they're sweaty or dry, or just the conditions in the air, I found even, it can make those readings change a little bit. And sometimes you have to tweak the threshold value in order to get it to like really know for sure when it's being touched. So it looks like what happened there is that it toggled really, really fast, up and down, up and down. And that caused me to hit my limit there, and so now it stopped changing. I'm guessing after a minute or two or something, it will go back to working. Yep, exactly right. Yeah. The other thing that is interesting on the touch pads as well is they do have the touch slider. So I don't think there is a way to hook up the slider just yet directly to Adafruit Io. I wonder though. Let's look at what it does. Whoops, we don't need that. Actually, we could turn off the preview. Let's look at what it does if we go to add I think I'll undo I'm gonna delete the touchpad one for now. That way it's not sending any data anymore, and so it won't be causing my thing to throttle accidentally. I'm guessing if we refresh, that's probably gone. So it probably just takes a minute or whatever. Like that limit was it 30 per minute? So I must have just hit that because of that touch device there. Let's go new component. Let's go water sensor. Okay. And so one thing is, this does only let you select one pin. So it does look like this is currently within Whippersnapper set up for digital only, not analog. So with Whippersnapper, it's not going to be able to tell you the water level, but just be able to tell you water exists or not. And in that case, possibly we could actually use could we use the PIR port? X. Sort out the board. That's on GPIO 16. No. Yeah, it can't work because, well, I mean, it can't work in the PIR port because the signal pin is opposite the ground pin, whereas in the PIR port, signal is in the middle, ground is on the right, positive is on the left. So these would need to be swapped around, basically. Signal would need to be in the middle, and then maybe we could use the PIR. So for now, though, I think we could try to use one of the JSTs. So let me just take another maybe 2 minutes. I'm going to try to grab a breadboard, possibly, and JST connector or two, and maybe some female headers or something that we could try to connect this with. Let's see, do I have this one? I might. I'm not. So one day I did, one day when I was making an order, I did throw in like 3 or 4 of all the JST connectors I could find that were in stock. So, but I don't know what all of them are off the top of my head. And I know there were some that were out of stock at the time. So there were some that I don't have. But yeah, this one would be perfect if I've got them. So let me run, check on that. I will grab some parts and I will be right back. Alrighty, I am back and I come with presents. So let's pull the camera. Let's fix that. So I do not have that one specifically. What I do have though is we have 3-pin JST to the male pin headers. So we could use that along with a breadboard, or we could try this, which is 3-pin JST with alligator clips. So maybe we could alligator clip onto these pins here if there's enough room. Let's just see if there's actually... there's really not enough room to alligator clip them. You could maybe do it, but it would... oh, sorry, I'm not on the camera there, but basically the alligator clips, they're just a touch too big. They would probably be trying to touch each other, and so we'd have to keep them apart. Set up the NeoPixel. Oh, nice. Yeah, I just used the PIR sense pin there. Awesome. So let's do the breadboard, I think. Let's, we don't need any of these wires. This is just from an old project. Take those out, and let's go. Let's try to keep this on camera here. You know what I could do for now? Make this bigger. Okay. So we've got that plugged into the breadboard. So now I'm just going to go match up the colors. So black is ground. It's going to go in minus. Red is positive, so that's going to go in plus. And signal is white. That's going to go in the S. And then we can plug into one of our JST ports here. Let's see. These do have to double check the direction. Okay. This way. Okay. Clicks in there. Hardware hacking with foamyguy, yep. Indeed. Okay, so we got that plugged in. I think what I'll do is maybe set this like so. And let's go ahead, well, maybe let's move it just a little bit closer here. It's gonna be tough to keep everything in frame. Maybe we could come up just a hair. Do that for now. So let's go back to Whippersnapper and finish adding that. Whippersnapper, we are on A0, right? Yep, because we plugged in that JST to A0 there. Does not look like it's plugged in all the way, but ah, yeah, there we go. Was not actually plugged in all the way. So there's that. Again, let's try to pull that back a little bit. So A0, and let's call this Fun House Water Sensor. Create. We have no data yet for the water sensor. Let's look at the, well, I mean, the feed it will be empty. So this one does not have the interval. It looks like you don't choose whether it's an interval or a on change. So what I'm going to do is kind of just take some of the sweat from my water here, my drink of water, and I just touched it right on there. I really should have done it on the camera though, shouldn't I? Let's do that. Let's put this back. You can kind of see there it's a little wet. So what I'll do is I'll wipe it off. And did I get it all? Let's see. Yeah. Okay, so now it shows dry. So again, what I'll do, my water here has got a little condensation on it, so I'm just gonna grab a little of that, stick it right on there, and you can see now it changes to wet. And then if I wipe it off, just by drying off my finger, getting all the water off of there, you can see that does switch it up to dry. So that's awesome. We could very easily set up a water monitoring thing, just like how it is in this guide here, right? We could just position this thing, kind of clip it onto the side of the cat water bowl there, and it would be able to tell us when it is low enough that it's not touching the sensor anymore. And I noticed here it does have like trigger. I have not looked into this part, but it looks like maybe reactive trigger. Let's take a look through here. I've not actually used triggers before. Action. Well, that's interesting. The drop down showing up way up here. Publish a message to, send a webhook message to. It looks like you could have it take some action whenever this thing changes. You could have it, if you had a Plus account, you could have it send an email. With a regular account, you can send a webhook or publish a message into an Adafruit Io feed. So you could have it updated a separate feed if you wanted. So I'll leave that for now. But yeah, this has been pretty fun. I'm super excited about this project because I really like the idea of, again, making stuff easier, right? Like, I am a programmer by day, right? This is my career. I've been doing it for a little while now, so I am not necessarily the target audience for all of this stuff that's kind of like no-code stuff, but I recognize and I really appreciate all the work that goes into this to get it to where folks who have no experience with programming are able to do some of the same kinds of things that I can do with my years and years of experience. I really like stuff that does that, and this is huge for IoT devices to be able to set all these things up, never write a single line of code, and still get all of this stuff done is really, really awesome. Hey Johnny, how's it going? Hot day? Yeah, it's a little warm here as well. Was thinking about cranking the air a little bit, but I ended up leaving it. First day of vacation, nice. Yeah, I'm off on Monday for the U.S. holiday, Independence Day, or lots of folks just call it July 4th, which is actually on Sunday, but lots of places are closed on Monday this year, including my office. So documentation, it looks like this just goes back to learn. I assume there will be some more specific documentation at some point. Can I get my tab back? Go back one. Yeah, so I clicked on documentation, it just takes us over to learn, and then this one looks like it just takes us back to Adafruit. So I assume those links will probably get filled in with different stuff there. But yeah, this has been awesome. So huge thanks to Brent, obviously, for all of the work on Whippersnapper. I don't know if there are other folks working on this. If there are, definitely huge thanks to them as well. I don't know, unfortunately, who they are by name, so I can't call them out specifically. But I know Brent works a lot on this stuff. That's who showed it off on Show and Tell. So huge hug report. Huge thanks to Brent for all the work to get this thing working, and then as well for inviting me to the beta. Brent reached out to me to ask if I wanted to do the beta, and it's definitely interesting to me. So of course I jumped on that opportunity. So again, big thank you to Brent for making this possible for the stream today. In more ways than one, definitely. So with that, I think we will. I think we'll skip the PyPortal for now. Maybe we'll play with the PyPortal next week. Or at some point, I also have a Metro ESP32. So at some point, maybe we could use that device as well and hook up some more things. I'm super interested to keep an eye on the components list here and see these list of components grow, because I would love to be able to just do like temperature humidity sensor, which is built into the Funhouse. Control the speaker maybe. Plug in other types of sensors like accelerometers and things like that. And so yeah, I'm sure they're going to be adding more and more devices all the time. So I'll keep an eye on that for sure. But I think what we'll do next, I'll probably go for about another hour or so. And I think what we'll work on is that group max size stuff. So some of these PRs are in already. We'll do some reviewing, and maybe we'll also do some, creating PRs as well to make those changes to max size. So let me clean up my tabs a little bit here. This one we want to keep because this is the big list of them. This is the Whippersnapper page. I'll close that for now, and we'll close a bunch of these for now as well. Let me see who made this one. Was this Melissa? Yeah, Melissa. Huge thanks to Melissa as well for this watering sensor guide. This was nice to be able to see the pinouts and everything and how it all hooks up. And in this case, we didn't need to use the code, but like if I were sitting down to write CircuitPython code, I would be coming to this page right here, looking at the code that Melissa wrote for this project and then adapting it to to do, you know, whatever I wanted. So thanks also to Melissa for the work on that guide for sure. Okay, let's go here and let's take a look. I think one of these cursor control, I think this one got updated since I looked last. Yeah. Oh. Workflow. What? But it ran before. Interesting. Okay, well, we'll just do approve. I wondered, did GitHub like reset the permissions on all of the workflows? So that's a newer feature. They added that so that basically the deal is, you know, obviously workflows, actions run code on a server inside GitHub, and you know, people are a flawed animal, and so people took advantage of this by trying to make it, you know, mine cryptocurrency or carry out other sort of unscrupulous, scammy type behavior related to cryptocurrency. I don't know the specifics of what they were doing, but basically they were making edits to the actions files that then caused when they ran to try to do something to generate cryptocurrency for them or steal cryptocurrency or something like that. And so in order to combat that, GitHub, they added this check where, like, if you are new to a project, if you've never contributed to that project before, or maybe there's more that goes into it. I'm not actually sure the specific trigger, but the idea is new folks who haven't contributed, I think, it won't just run their actions by default. That way, like, a person who has contributed or a person who has permission within the repo has to actually come and click that approve button like I just did a moment ago. And then after that gets clicked, then it will run the actions. That way, if a person puts malicious code in there, you have a chance to see it ahead of time and be like, no, we don't want to run that because obviously it's not related to this project. In this case, I'm fairly certain Lay Samurai did not do that. I probably should have looked anyway just to be safe, but I think we're probably okay here. Lay Samurai has done a lot of good work on a lot of different libraries, so I think they're a trustworthy person. I don't think they would have done that. But that's run. It is weird though, because it ran the actions up here before, and so it allowed them to do it before, but for whatever reason it didn't do it on the latest commit. So, and in this case, this is the cursor control library. So what I'm going to do is pull up my camera. I'm going to clear out some of this stuff a little bit. I'm going to unplug the funhouse for now. Yeah, for sure. For sure. You're welcome for the preview, Dexter. It was really exciting for me as well, actually, to get to play with that for sure. So let's try to tidy this up just a touch here. And I think what we'll do is, for cursor control, we want to use this, which is a Pygamer, because it has joystick, which is what the cursor control library is meant for. Either a joystick or a D-pad. So we're going to plug in the Pygamer. Maybe I should run this cord around the other way, actually. Let's see here. And Pygamer also has a physical switch. It's real tiny, right up here next to the USB, so usually I forget about that and I plug it in and then I sit here for a second and wonder why it's not turning on. Eventually I remember it has a switch, so I'll clean off the screen a little bit as well. Yeah. So this is running some sort of image load example, and what we want to do is switch it back up to the cursor control. And we'll test out the changes, and if everything is good, then we will approve this PR and merge it. So got this open because I worked on it just the other day. Let's see. I may have to take another brief minute away and feed the cat. He's getting awfully always likes to come up and rub against your legs and stuff whenever he's ready for food. He's here doing that. So let's go get the right project open. Cursor control, this window. And I made some changes because I was testing out this PR and I noticed a few things that needed to be changed still. So what we will do is just roll those back. Hit rollback. So that's going to undo all the changes that I made locally. We wanted to undo all of them for every of those 3 files. That's going to put it back to the state it was in on this branch that I happen to be on, which is the max size branch, which is actually Lei Samurai's max size branch, and it's the one from this PR. And I think I can do update, maybe? No tracked branch. So I could give it an upstream and then I would be able to pull it. But I think it's probably easier just to go back to main, delete max size. So now my local copy is gone, and then just do checkout again. So GH, I'll do clear, that way my terminal prompt will change here and show main. And then GHPR checkout 24. Oh, there's a new version of GH. But looks like that worked. And now we have these examples, and you can see max size. That's what the change that I had to make was, is this still had max size in it. And so it is removed now. And so all we really need to do is just check out these examples and make sure that they are still working. So we're gonna go new. Let's see, we can close this. Did my TO reconnect? Let's see. Yeah, it did. And we're on a Pygamer now. So TO, because it does automatic reconnecting, it disconnected from the Funhouse. And when I plugged back in the Pygamer, it took the same, /dev/tty acm0. So it reconnected to that automatically. And I am on version 6.3.0 there, which is good. That's the current stable version. So that is what we want to test against. So we'll go load CodePy. And we'll just take this. I think actually buttons text, I think that's the most advanced example. So let's start with the simple one first. Do we want to keep this? No, I don't think we need to keep this. Maybe we can actually. Code, this is ppm image test. Okay. And now we'll go back to code. Now we can erase it and paste in the cursor control one. So let's go like this and like this. And we just save it. And we are currently in the REPL, so we do need to go Control D to go back to running CodePy. You can see it put the little mouse cursor there on the screen. I will actually, while I'm here, at least put some of this stuff back. So give me 1 second here. I'm going to put my little JST connectors back in their bags. I should grab, hey, thanks for that link, by the way, Dexter, for those, that female JST ones. Next time I make an order, I'll throw some of those in if I've got, if they're in stock. Because it's always nice to have, like, a bunch of those little connector cables on hand. Let me also unplug this one real quick. A little harder. I have any fingernails right now. Maybe we're going to be leaving this one. Let's see. There we go. Okay. Sorry, I know this is not the most exciting thing in the world, but truthfully, I am, sometimes have a problem with putting stuff back, truthfully, so it's good when I do remember to do it need more cables. Yeah, you can always use more cables for sure. When I do remember to actually put stuff back, I try to be good about it, but I'm not always very good. So here you can see it put this little triangle mouse icon on the screen, and when I move the joystick, that thing will fly around. So it's pretty quick, but you can see it's working there, and I'm able to move the cursor around. And that is all this example is supposed to do. So that one is working correctly. We'll check out the other two as well. Custom cursor is the next one. And this is basically the same thing. The main difference is that it is using a bitmap as the cursor instead of the default mouse triangle shaped one. Got Friday and Monday off, nice. Yeah, there was a couple folks at my office that took off Friday. I ended up working for a while. But we do have, all of us have Monday off. So this one has got the custom cursor, so you can see there it's a little white outline of a box, and that one is also working as well. It's flying around when I use the joystick, so we're looking good there. And so we will check the last one. And this one's got more to it. I believe it makes a couple of things. So let's see here. It made 4 buttons and some text that gives you output about what's going on. So you can see here I'm moving it around. It's a little slower. And maybe if I don't know if I'll be able to get the screen to focus very well. But basically what we've got is these 2 buttons over here, they say speed plus and speed minus, and then these 2 buttons over here say scale plus and scale minus. And basically what you can do is, my box is coming apart here a little bit, let's snap that back in. What you can do is move the cursor until it's on one of those buttons. So like we can get to where we're pointing at the speed plus, and then we can press the A button over here, and it will click it. You can see there that it's changing the background on the button. And now that cursor moves a little bit faster. And you can also see the text right here. It says speed 13 pixels. So basically, you know, each time it pulls the joystick, if the joystick is in a direction, then it will move, you know, that many pixels in that direction. And of course, the more pixels it moves, then the faster it will seem to be moving. So if we go to speed down now, we could chunk it back down until it's quite a bit slower. And it does look like everything's working. And then these 2 are scale, which those are going to change the size of the cursor. Obviously, you can see there the cursor is getting to be ginormous. And so you could go scale back down to get back to regular size. So that looks like it is working good. The one other thing I will do just real fast is I'll go get grep max size, just to make sure there's no more usages of that. And it looks like there are not, so we should be good to go here. We'll go back to the PR, and we are good now. So we can do resolve maybe, or it doesn't look like it changes. Doesn't look like it has a resolve button. Whatever reason, so we don't need to worry about that though. We can just go here and review and approve. Changes look good to me. Tested successfully. Six 6.3.0 is what we were on here. We'll do approve, submit, and then we can go ahead and merge this as well. Merge, and then after we merge, we always want to make a release. So that way the new version gets included in the bundle, because the bundle takes the newest released version. So if we don't make a release, then the updated version will not make its way to the bundle. So we're going to go to the release page, and this is the way that I like to do it, is you get an edit box of the old one, and you get another tab here with the new one. This way you can copy this message, which is typically the same from release to release. And then basically we just need to choose a version number and give it a title. So I've been bumping the second number on most of these. Actually, truthfully, the way that I've been doing it is if the only thing that changed was examples, then I'll bump the minor version for this particular change. But if the library code itself changed as well, then I've been doing the middle number, just because this change does make it incompatible with older versions of CircuitPython. Older versions are still going to be requiring that max size. And so this would actually crash if it ran on a version that's old enough. Of course, though, in that case, we do want folks, obviously, to update to the newer version. But just because it's incompatible, I think it's good to go ahead and raise the at least the middle number. So let's take a look at files changed and see if it's just examples or what. So in this case, there was some fixes as well to other things, like in the README and a bunch of stuff that was for the docs building. So Lay Samurai did a bunch of other work to get the docs going as well. Let's see, this one is in which file? Cursor control. Okay, this one is, it does have a change in the library itself as well as in all the examples. So we'll go middle number, and the previous one was 225, I think, right? Let's just double check. Yep, 225. So let's go 230. And I like to include it in the title as well. 230, remove max size usage. So we can leave the rest of this the same, I think. We do want to target main. All of this stuff should be good. And I always like to, because I messed this up one time, and since then I always like triple, quadruple check. So I'm just going to, check again to make sure this number 225 is definitely less than this number here, 230. Because if you accidentally put a number that's lower than the previous one, things go bad. It causes some stuff to fail, and we don't want that. So now I'm always in the habit of triple checking that. So we're good now. We'll publish this. And so that's our new release there. And if we, let's see, let's get back to our other tab here. Oh, that was our other tab. Okay, I guess it was just gone then. How does reopen? Does it only do it if you right click on a tab there? Really where I want to go is back to the issue, this one. Which is one of the really cool things about this is all of it's in GitHub here, and it's kind of self-updating. So because we went and merged that PR, it actually shows right here that it has been merged. So this is a nice like checklist we can work from. So I think Lay Samurai and Jose, yeah, are working on the clue one. So we'll let them do that one. Dash display, I'm not actually sure what that is. What is this library? Creating Adafruit Io dashboards. Let's take a quick look at what it's doing here. Mqtt. Publish lamp. IoT.get, IoT.loop. Okay. Not sure what lamp. I guess lamp is the LED maybe? Eval lamp. Hub lamp. Interesting. don't know what this gets past. We should be careful though using eval like this because it'll try to execute Python code. I don't know, where does this get called though? So publamp of 2. It's in the publish method of here. Interesting. I'm not actually I'm not 100% positive what this does. It's creating the dashboard on Adafruit Io. Do you need to have feeds set up though? Have a display. Pass it to hub. Let's go back to the PR. See which files changed. So inside the library, inside examples battery daughter, and examples advanced test. Okay. Let's take a look at those 2 examples and see if I actually have the stuff to test them. So this one does not have a comment that gives us a high-level look at what it does. So it does set up the 3 buttons, set up 2 of the cap sense pads, create an RGB group. RGB set color, door color, on door. Let's do lamp and temperature and humidity, neopixel and battery, and door. Actually sure what it does though. Is it creating the dashboards on Adafruit Io, or is it reading from a dashboard on Adafruit Io? We could try running this one. We may end up having to skip. We may end up having to skip it now just because I'm not sure what all setup is required. Let's give it a try though. Python dash display. Let's copy this. I'm gonna clone it, so make a new terminal. So now we've got that. Let's open that in PyCharm. So it's not gonna be in recents. That was dash display. As this doesn't refresh. There we go. Yep, we could go this window. So we want to check out the PR, which is, oops. Number 20? No, number 2. Submitted 20 hours ago, number 2 though. Back to PyCharm and go GHPR 20. No, checkout, GHPR checkout. Nope. Checkout. Oh, I just did it wrong again after I set it and everything. Okay, checkout 2, there we go. And let's just do the grep. Let's make sure we got all the instances. X size. Yep. Okay. None of that is left. So basically, we just want to run the example with the updated library, and it does look like they're made to run on a funhouse. We're gonna go show files here, and I'll swap back over to the funhouse. Unplug this. You can see the screen stays on there even though I unplugged it because it does have a battery as well. So turn that off. The battery is extra. You have to have the battery and plug it in. It's not like built onto the Pygamer. It's got a nice little plug for it, but you do have to add it on. Plug in the Funhouse, and we will need to go back to CircuitPython. So, downloads, and we can, I think, just use 700 Alpha 3. There we go. Got some of the cat hairs up here. It's one of the things about having cats, their little hairs get everywhere. Okay, there's our CircuitPy. I always like to just double check. I don't really run into problems with it typically, but I always just like to double check, make sure I'm on the version I expect after I do that. That's looking good. We'll go, did we change CodePy? We haven't CodePy. We do want to keep this. Yeah, this is our, Control D, no. Control Shift D did that. Interesting. We do want to, this is a web image. We already have a web image actually. That's all right. Let's go web image. Save, replace that. And then we'll load code. And we'll grab the example. We'll do advanced test. It is looking for stuff inside of my CircuitPy. Excuse me, my secrets py, which you can see here where it says from secrets import secrets. If you caught the beginning of the stream, I talked about secrets.json versus secrets.py, and so this one is the one that's using secrets.py instead of JSON. So I'm hopeful, though. I'm really happy to see that Whippersnapper is using secrets.json, and I'm hopeful that we are going to be working towards moving the rest of everything, even though it's going to be a lot of work, to use secrets.json instead of secrets.py. So I'll paste this here. It's going to fail because I haven't set up the libraries or anything. So like if we put this, I know the chat's going to cover part of that up. Maybe we can do it like this. See where that gets us to. There we go. Let's turn that preview back off. So if we just save this, I think it should crash because we don't have the right library or something. Yeah. So we don't have display text yet. So we can use Circup to install that. That'll go and do its thing. This will restart automatically. Next one we're missing, though, still missing more libraries, mini Mqtt. So we'll install that one. Reboot again. We're missing Adafruit Io. So I'm guessing we have only another maybe one or two or so of these to do. And then for the dash display one, we'll copy it out of the repo that is checked out to that PR branch. Yeah, there we go. So dash display is the next one. It says we could install that from Circuit, but what we really want to do is actually copy that from our repo, since that's what we're trying to test. So we'll copy this file, go to CircuitPy, we'll go to lib, we'll go paste. Okay, still missing a few more shapes. Okay, we made it past the imports. We're connecting to the network. And connecting to Adafruit Io. Getting lamp temperature, humidity. NeoPixel. Door. So I'm guessing that these are not filled in because I don't have those feeds created. If I went back to Adafruit IO, so one thing is I even though we don't have these feeds created, I do think that we have seen enough to know that this PR is good, because this PR is dealing specifically with max size within group, and if there was any problem with that, then this stuff would not be able to display. So I think we're actually good enough here to approve this, at least for this example. We'll test the other one as well, but I am curious, just because I have not played with this dash display before. Oh hey, my feeds do show here now. It's interesting, when you go to show all, let's see, let's do that again. Wait, what? You all. How did I get to that page? Huh. IO. So this was dashboards. And then I clicked feeds, and now they do show here. But if I do view all, then they are not there anymore. Only these ones are. And sometimes they're not there. Like when I went to dashboards and then went to feeds, now they're not there anymore. It's like you have to be on Adafruit IO here, then click feeds and they show up. But if you're on a different page and you click feeds, they don't. So that might just be because it's still in beta. I don't know. Like I said, I assume there will be a new whippersnapper section for it, but that's interesting. But that is not necessarily what we're looking for right now. We want to add a new feed, which is we go view all, we go new feed. I don't know if it'll matter what group we put it in. I don't think so. Maybe we'll make, I think we want to make it match one of these. Let's try, is it just lamp? Yeah. Lamp, let's set up a lamp feed. Testing dash display. Put it in the default group, create. Oh. We're at the limit of our feeds. We could remove these ones. Yeah. Test dash display. Add data. V1. And does this show up here now? Ah, yes, this does show up here now. So lamp does have a little 1 by it there, and I'm guessing if we made it a 0, maybe we could go like this. We made it a 0. Yeah, that will change there. And so that's cool. So basically, it looks like this library is used for essentially making something like the dashboards, which are here, where you can add your different feeds to the screen and show their current value. It's basically doing something like that, but on a CircuitPython device using Display Io. So I will not, for right now at least, especially since I'm at my limit of feeds at this point, I will not go through and make all of these. But we can see that LAMP is here, it's pulling data, it's updating, everything seems to be good to go. And of course, the main thing we're interested in this case is just making sure that everything displays, which it does. Because again, group is a thing that changed, which is related to all the stuff that's on the screen. So we'll double check the other thing that changed, which was battery daughter. Let's run that one as well. Copy. Pull up the camera while we do it. So let's see. We have an import error. Get back to our terminal here. So this one is trying to use it's a battery gauge. I've got one, but I don't know exactly where it's at, so I'm not gonna mess with trying to plug it in for right now. NeoPixel. SD1306, what does this code do? Oh. Actually, yeah, we will not. Okay. Well, two things. Yeah. Two things, actually. This is not made for the Funhouse. It's made for a device with an external screen. That's what so this is used for the external screen. And down here, where it's making a display bus and making a display right here, this is setting up the external screen. I guess we could do this, take this out. But the other problem, the next problem we're going to run into, yeah, it's not even worth, honestly, making all these changes, because the next problem that we're going to run into is that this is made for airlift devices, basically devices that use an ESP32 coprocessor, whereas this Funhouse right here, it uses the ESP32S2, which is all in one. The main board is the Wi-Fi processor as well, whereas like this device right here, this is a PyPortal, and on this device, the main CPU is inside this chip here, and the Wi-Fi actually is a coprocessor. There's a Wi-Fi chip inside of here, and the CPU talks back and forth using SPI to the Wi-Fi chip. So that's what this is set up for. This is actually set up more to use like a PyPortal, and not even necessarily specifically a PyPortal, but some device using Airlift, that ESP32 coprocessor, and then also specifically in this case it is set up to use this SSD 1306 I2C bus display, which I don't think that I have, or if I do have one, I don't have it ready to go, certainly, so I won't be able to check that out. But I am relatively confident, based on the other example, that we are going to be good to go there as well, truthfully. So we won't have a chance to actually run it, but We'll say in the PR that we tested the advanced test example. And this is looking good to me. Did we run our git grep? Let's see. I think I did. Yeah, got no hits there. Let me just make sure I have the syntax right. Like if I say secrets, yeah, this will return a bunch. Okay. Sometimes I don't remember if there's like extra flags or something. I know there's a line number flag and some different stuff, so don't know if you need quotes. I just like to do that with one that I know is there, right? Because I'm just looking at the code and I see secrets, so that way I just know my grep is working, and if there was a max size, that it would definitely find it. So this does look good to me. Interesting, it was originally capped at 25. I mean, I guess they just had to choose something, so it's really nice now that we don't have to have the max size before. That's actually another change I'm really excited about, because I like the way basically it works like a list now. You can just keep appending to it more and more stuff. You never have to worry about removing stuff. So these changes look good to me. So this is actually really cool. I never knew about this library. Honestly, this is the first time I've ever seen this library. This is actually pretty cool. If you do use Adafruit Io and you want to make make something to display output from Adafruit Io without having to write a whole bunch of code to do it more manually, this is pretty cool. So these changes look good. Tested. Let's go. I tested the advanced test example successfully on a funhouse with CircuitPython 700 alpha 3. I can never remember the right way. If it's dot, I think it's dot here and dash here. I don't know. They'll know what I mean, though. I do like to put them in code things, though, just so they're easy to copy paste. This is another one that is, it did not run the actions. I didn't notice that before. So we'll let that run the actions, and then as long as actions passes, then we'll go ahead and merge this. While that's running, actually, I'm gonna run just to the restroom real fast. I'll be right back. And let's go. Maybe we'll pull this up, and that'll probably be done by the time I get back. So I'll be right back. Alrighty. Ooh, hot tub. I wish I had a hot tub. I know my wife wishes we had a hot tub for sure too. We've talked about it a few times. Actually, when we were looking at houses before we bought this house and moved here, some of the ones we looked at had a hot tub, but ended up in this one, which is really super cool as well. But no hot tub in this one. 41 degrees. I'm guessing that's must be Celsius probably, which does sound pretty hot. Oh, 46. Doctor wants it even hotter. Okay, let's see. This does look like this passed. We can go back to here. Yep, it did pass actions. All checks have passed. We approved it. So let's go ahead and merge this one. And then let's go to make a release. So we are caught me by surprise. This one has 2 lines. I'm so used to copying this and seeing 3 lines there. I think the deal is that this does not have yeah, setup pi is disabled. It does not have, it's not deployed on pip. I'm guessing probably is because a lot of this stuff is specific to CircuitPython. Like, I don't know if mini Mqtt, I don't know if that's on pip. And I know for sure, though, the way that we do Wi-Fi, like socket pool and Wi-Fi and stuff like that, is different than CPython. So, oh yeah. Hey, doctor, thanks for checking in as well. Hope you're having a good Saturday. Let's see here. So we got this. What version were we on before? 101 is the previous version, so we will do a same thing as before. Let's just double check. I'm pretty sure it changed code in the library as well, right? Yeah, this one is in the library itself. So the library and then 2 examples. So because something changed in the library, I will go ahead and do the middle version number there. I don't know which. It's like major, minor. I don't know what the middle one is, but that's the one we'll do. Because again, it is incompatible if you do have an old enough version of CircuitPython. So 110, and this is remove max size usage. And again, I'm just triple checking here. We were on 101. We're going to 110, which is higher. Publish. Okay. That'll run some more actions and get ready for the bundle and everything. Maybe we'll do a couple more. Let's take a peek here. Dash display. This one we can check. And it didn't. Oh, actually, it just updated live right there while we were looking at it. So it was green for a second there, but then it changed to purple because it did get merged. So let's see what's the next one here. Display IO layout, we could do. The thing about this one, though, I think, yeah, there's a ton of changes. So basically, this one will need to, we'll want to at least check all the examples, I think. And there's a lot of them. Since I have only about 15-20 minutes left today, I think I'm going to save this one for later. Just because there is a lot within it to check. So let's see. Do we want to? So the ones that are open still are Clue, Display IO Layout, and Portal Base. I think we could do this one, I think. There are examples. So there are no examples in Portal Base because it's like a higher level library that is then used by the other libraries like PyPortal and MagTag, and there's a Funhouse library now as well, maybe that uses it. Matrix Portal, Major, Minor, and Patch. Thank you, Dexter. So yeah, we'll be changing the minor in this case. Or if, the way I've been doing it is if the only thing that changed was an example, then I've been doing the patch. But if the actual library code changed as well, then I've been doing minor. Yeah, why don't we go ahead and do this one as well. So Portal Base, we will, sure, I must probably have this already, right? Portal Base, this window, let's go fetch, and then GHPR checkout 42. What an excellent number. Okay, now we're on max size branch. So same thing that I'm starting all of them with. We're gonna get grep max size. Yep, looks like we're good there. No other remaining instances, so now we will need to use the PyPortal for this one. Or I guess maybe we, let's check actually, let's check. Does Funhouse, let's go here. Funhouse. So does this use Portal Base? Yeah, I think so. Yeah, totally does. Okay, so, and we already have the Funhouse plugged in. So let's actually just use that and look in examples. And as long as this does stuff with the screen, which label color, I'm assuming if it's got label colors, it must be doing stuff with the screen. On-off label. There's a switch. Oh yeah, there is a switch. But that's power? Isn't that mains power? I mean, not mains like the house, but main for the device. Yeah. Must not be the on-off they're talking about, though. Okay. This does seem fine, though. Yeah, this seems like a fine thing we could use to test, so we will do that. So what we want to do is get the modified version of Portal Base, which we're in the right branch already, right? Yeah, max size. Portal Base, go here. We're gonna delete the other one. I'm sure we have it, or nope, I was wrong. We don't have it yet, so we'll just paste this one. And then we will install the Funhouse library. I'll just use circup to do that again. And then we'll grab the example from here. We'll just go simple test. Let's do that so we could go Control A. We'll get the camera back. Let's see. We're not covering up too much. Yeah, that's pretty good actually. Okay, so yeah, looking good there. We don't have the PIR plugged in, so we're not going to be able to do that. But we can see everything did draw the... I touched on this here, and this changes to off. So that must be checking the capsense, and now I just press the up button right here, and now that little red up turns on there. Select button right there. Down button down there. We don't have any other sensors. We have the humidity and temperature. Maybe if I stick my finger on it, maybe it'll change the temperature a little bit there. Looks like it's going down, so my finger is a little colder than the air right now. So if I let go, then it'll slowly return back up a little bit. The slider is over here. So we can see the slider numbers changing there, and it looks like those are also changing the brightness of the LEDs, which is probably harder to see on the camera since I did turn the light back on, but you can see it's changing their slider on the screen. So it looks to me like everything is good to go here. So we will, I think we ran this already, but I'm a double checking kind of guy. I like to always double check things. Try the slider, yeah, thank you. The slider on this thing is really neat, actually. I like the way that thing, and the way the silkscreen works, honestly. Like, I never seen, before this device, I never seen touchpads that don't have, like, exposed copper. Like, I've seen touchpads that are just built into the PCB like this before, but usually it's, it's copper, right? You can see through it, whereas here, somehow they have just black and white, and none of the like copper or that shiny metal. Maybe it's brass or something. I'm not actually sure what metal it is. I assume copper, but I don't actually know. But these, like the birds and the tree over here, the way they're just black and white on the silkscreen, but still work as touchpads, is super cool to me. And then this one having the whole range there. That's really nice. Like, if you wanted to use this to be like a light dimmer or something like that, it's really awesome that you can do that on the side there. So let's see, this is working good, I think. And we did our grep, so we saw that there were no other instances of max size that got skipped. So I think we're good here. Oh, we need to do this thing. I should have done that at the beginning. That's right, we'll let it run. And then while that's running, I'm gonna put my gloves on here, actually. My fingers are a little cold, apparently, according to the old temperature sensor there. Okay. So that's running. I think we can just go ahead here. These ones just changed permissions only, file permissions. I'm guessing, let's see, there was only one commit. I'm not actually sure why the file permissions changed. I don't know by heart which one is what. Owner, read write, group read, public read. They went from 755 to 644. So this is where they landed. 755 must have been this, and also execute. So yeah, I think that does make sense, right? It doesn't need execute because it's not like at least in my experience, I don't think you need execute on a Python script in order for it to run. Certainly not on a CircuitPy drive. Honestly, I don't even know if the CircuitPy drive has these concepts of read, write, or execute and stuff like that. I'm not sure if that's even built into the file system. So we don't really need execute. And as long as it passes actions, I think it's probably fine. I'm not sure if it fails pre-commit or pilot or black or something, if those are like that, or I'm not sure how Samurai knew to change them, but I don't think it's a problem, certainly. It seems fine to me. So we will review this, and this will probably be the last one. I'll probably kick off after this one. So proof here, these changes look good to me. Tested successfully with the simple test script from CircuitPython 7.0.0 alpha 3. Maybe I'll link the simple test just in case if somebody else is here and wants to see the specific thing. Okay. And this did pass actions now, so all checks are successfully passed there. We can merge this as well. We'll make a release, and then I'll probably call it a day after that. So merged. Other issue here. Tag. Interesting. I stack exhausted. Sure about that. Definitely unrelated to what we're doing though. Yeah. Right back to this person after I get off. Okay, we want to make a release. So 172 is the current one. And it did change code in the library inside the graphics file, which of course in this case there are no examples since PyPortal and Funhouse, that's the other libraries, the ones that use this one are the ones where the examples are at. So we'll go minor again. Let's see, we had 172, so we'll go 180. Oops. Okay. There we go, 180. All right, so that'll run the rest of the actions. It'll finish it up to get it ready for the bundle. And I think we are going to call it a day for there. So thank you, everyone, for hanging out. I hope you guys, I hope you folks enjoyed the sneak peek at Whippersnapper. I know I enjoyed playing with it. I'll probably bust out the PyPortal at some point, try it out on that device, and I'm definitely excited to see more microcontrollers, like maybe the Metro ESP32S2, and perhaps others get implemented, and as well more components. I'm excited to see what other components they add. So I'll be keeping an eye on that. And of course, if anyone is interested in this Display.io group stuff and helping out, you can see here we have an awfully large list that Lay Samurai put together for us. So if folks are interested in getting involved, this is a pretty good place to get started. There's going to be a lot of these PRs coming up. So, you saw the review process that I went through here. If folks are interested in doing the same kind of thing, you can do your reviews. Or, of course, there's also a bunch of these where the PRs are not created yet. So you could actually go through and do the changes like Lay Samurai was doing to remove the max size usage. But that's going to be it for now. So thank you again for all the folks that came and watched. Dexter and Doctor and Johnny. And again, I must say as well, huge thanks to Brent for getting me hooked up with the beta. And obviously, of course, for all of the work on Whippersnapper. I think Brent did a fair amount of that. But if there are other folks working on Adafruit Io, I definitely say thank you to them as well. So that's going to do it for now. Thank you all for tuning in.